Hello, Physics Ninja here, and welcome to the first video on my series on waves. In this video we'll be looking at some of the basics of wave theory, the relationship between waves and energy, and the frequency of a wave. By the end, you should be able to state that waves transfer energy, define the amplitude and frequency of a wave, explain the relationship between energy and amplitude of a wave, be able to calculate the amplitude and frequency of a wave, state the units of amplitude, state the symbol and units of frequency. So what is a wave? You'll be familiar with all kinds of waves, but they've all got something in common. All waves transfer energy from one place to another. You'll be familiar with water waves. You should be familiar with sound waves. Maybe you know that light travels in waves. Light waves are part of a group called the electromagnetic waves, but we'll cover them in more detail in a later video. The visible light you can see is a small part of the electromagnetic spectrum, but there are other forms of electromagnetic waves, like radio waves, X-rays, microwaves, and here using infrared waves to pick up heat signatures. Nice. There are other types of waves as well that we won't cover here, like P and S waves that are caused by earthquakes. They're a bit beyond the scope of what this video is going to cover. So now we'll take a look at the energy that a wave carries. As mentioned earlier, waves transfer energy from one place to another. The amplitude of a wave is the height of the wave measured from its centre line, or its axis. You measure it from the axis to the crest, or from the axis to the trough. The amplitude is measured in meters. The more energy a wave carries, the greater its amplitude. You can see this when the ripples created on a pond. As the waves spread out, their energy is spread out too. As a result, the waves get smaller in size as the wave spreads and disperses. In the 2011 Japanese tsunami, the waves were caused by an offshore earthquake. It produces massive waves causing devastation on a biblical scale. The tsunami was caused by subduction of a tectonic plate under another, creating a wave with enormous energy that spread out to hit the Japanese coast. So look at this wave. It has a height of 3 meters from crest to trough. So what's the amplitude? I'll give you a couple of seconds to think about it. Got an answer? Well, if the height of the wave from the crest to the trough is 3 meters, but the amplitude is measured from the centre line or the axis, this means that the amplitude is half of that, 1.5 meters. So now we'll have a look at the frequency of a wave. The frequency is the number of waves per second. The frequency is measured in hertz. 10 hertz means that there's 10 waves being created per second, or passing a point per second. The unit's named after Heinrich Hertz, who was a German physicist from the 19th century. He did a lot of work in those elusive electromagnetic waves we mentioned earlier, before tragically dying at the age of 36 from disease. If frequency is the number of waves per second, it allows us to make a sort of equation. The word per to me means divided by. So if the frequency is the number of waves per second, then we have the number of waves divided by the seconds or the time. Take a little look at the wave here. I'm going to keep this running for a few seconds. What I want you to do is I want you to pick a point where the waves are entering or leaving the screen and count maybe 10, 15, 20 and time how long it takes for those waves to pass that point. I'm going to keep this running for about 30 seconds. Ready? Okay, start counting. Okay. Me personally, I counted 20 waves, and when I timed how long it took for those 20 waves to pass a point, I managed to get 20 seconds. So if the frequency is the number of waves per second, or the number of waves divided by the seconds, then I get 20 waves divided by 20 seconds, or a frequency of 1 Hz. Please note that the frequency doesn't need to be an integer number. You can get 1.5 Hz, for example. I've got a wee example question here for you to do. If 15 waves wash up on the shore in 1 minute, calculate the frequency of the waves. Feel free to pause the video at this point. So, the frequency is the number of waves per second. So the 1 minute needs to be converted into 60 seconds. This gives us the 15 waves divided by the time, 60 seconds. And this will give us a frequency of 0.25 Hz. So, after all that, these are the outcomes that we had a look at earlier. You should know that waves transfer energy. The amplitude of a wave is the height in meters, measured from the axis to the crest or the axis to the trough. The frequency of waves is the number of waves per second. The greater the energy of a wave, the greater the amplitude. You should be able to calculate the amplitude and frequency of a wave from a diagram or a basic question. The units of amplitude is the meter, and small f is the symbol for frequency, and they're measured in hertz. Thanks very much for watching the video. Until next time, take care.